Hello everyone, welcome back to another MCR3U1 video, and today we will be diving into some multiplying and factoring of polynomials as we continue equivalent algebraic expressions. So without further ado, let's get started. Here's the course outline, and you can find some more practice on today's topic in these pages right here. Page 95 to 97 will cover multiplying polynomials. Page 102 to 104 will cover factoring polynomials, and there's also a chapter review that covers everything we've done so far on pages 105 to 107. So I recommend you try some of these questions after the video. Moving on to the success criteria for this lesson, we will learn how to multiply polynomials using the commutative, distributive, and associative properties. And then we will go on to some factoring of polynomials using these methods that you see on the screen. We will do common factoring, factoring by testing variable values, factoring by grouping, factoring as a difference of squares, and finally trinomial factoring. So here we go. First, let's look at the three properties we need to know to multiply polynomials. We already have learned the distributive property, which we use to multiply the term outside the brackets to each term inside brackets. So in this example, we just take A, multiply by B, then multiply by C, and then multiply by negative D, and then we get this final expression over here, right? We already know this one. Next, we have the commutative property, which allows us to break down by a binomial or a trinomial, or any polynomial with more than just one term that multiplies to another polynomial. So here we have a binomial, which multiplies to a trinomial, right? And what we can do is break up the first expression by saying that each term in this binomial right here, right, individually multiplies to the second binomial, and then we can add or subtract the new terms together depending on the sign of A and B. So in this example, right, we have this binomial, and we can break it up and say that just A multiplies to this whole trinomial, which is right here, and then just B multiplies to this whole trinomial as well, which is right here. And the sign before A is positive, so we're going to keep A positive. And the sign before B is positive, so we're going to keep B positive. If this right here was not a positive sign, if it was a negative sign, we would have a negative sign here as well, right? We could also do the reverse. We could say that instead of this, right, we could break up this trinomial and say that C times A plus B, and then D and A plus B minus E, A plus B. So we can break up either one of the polynomials and put it in this form, right? Where each term in that polynomial multiplies to the other polynomial, okay? And finally, we have the associative property, which tells us that when we multiply, we can multiply whichever variables or numbers we want first, and it will still give us the same result. So over here, we multiply B times C first, then we multiply the result to A. Over here, we multiply A times B first, then we multiply the result to C, right? And we could even say that that equals A times C, right? Multiply A times C first, and then multiply the result by C. It's all the same. So now let's get into some examples. The first example here says, expand and simplify this expression, which says negative 2x times a plus 4 all in brackets squared, which is the same thing as saying negative 2x times a plus 4 times a plus 4, right? Because when you square a number, for example, 2, it's the same thing as saying 2 times 2. So if we multiply, or if we square a plus 4, then it's the same thing as saying a plus 4 times a plus 4, right? Same thing. Okay, so now what do we do first? So we can use the properties that we just learned, and the associative property tells us that we can actually multiply any one of these, right? First or second or whatever we want. We can multiply anything we want first. So what I'm going to choose is that I'm going to multiply these two binomials together. So I'm going to leave this negative 2x to the side for now, right? And now I'm going to use the commutative property to say that a plus 4 and then 4a plus 4, right? So I'm breaking down this first binomial, and I'm multiplying each term by this binomial, right? Now, we're going to multiply everything in. We're going to use now the distributive property to multiply everything in. So now a times a will give us a squared. A times 4 will give us 4a. 4 times a will give us 4a. 4 times 4 will give us 16, right? Now, if we collect like terms quickly inside these brackets, we will end up having a squared, and now we have 4a plus 4a. We will get 8a plus 16, right? And finally, we use the distributive property again to multiply this negative 2x by everything inside the brackets. So negative 2x times a squared will give us negative 2x a squared. Negative 2x times positive 8a will get us negative 16, right? Because we multiply the coefficients, and we multiply the variables, just x times a. And finally, we have negative 2x times 16, which will get us negative 32x, right? And that's our final answer. So now on to question number 2. It says determine if x minus 4, all in brackets, times 2x squared plus 5x minus 6 and 2x squared times x minus 4 plus 5x times x minus 4 minus 6 times x minus 4 are equivalent. So it's asking you if this expression is equivalent to this one. So here you'd be inclined to, just simplify everything, multiply this binomial to this trinomial, or, expand all this, but that will take you a really long time. What you could do is use the properties that we just learned, for example, the commutative property, right? To say, or actually we will use the distributive property in this example to multiply this whole binomial by each term inside this bracket, right? So if we do that, if we bring this down here, x minus 4, 2x squared plus 5x minus 6. So the distributive property tells us that we need to multiply whatever is outside the brackets by everything inside the brackets. So this would be the same thing as saying x minus 4 times 2x squared plus x minus 4, 5x plus x minus 4, negative 6, right? And if we write that a little differently, we can say that 2x squared times x minus 4, and then we can say 5x, x minus 4, and then we can say negative 6, x minus 4. And this is exactly expression 2, right? So now from this, we can say that expression 1, which is this right here, is expression 1, is equivalent to expression 2, right? Because once we simplified it, right, or once we did the distributive property, we can see that they're exactly the same. Okay, so moving on to question number 3. It's a word problem, and it says a cylinder with a, I think this is supposed to say has, a cylinder has a top and bottom radius of 2x minus 1 and height of also 2x minus 1. And it says write a simplified version of the surface area and the volume. And there's an extra b here. So let's do a first, right? So surface area, the equation for surface area is given right here, is 2 pi r squared plus 2 pi r squared, rh, sorry, right? So we have to substitute in the radius and the height. And now we know the radius is 2x minus 1, and the height is also 2x minus 1. So if we just substitute these two in to this equation for the surface area, we will get 2 pi times r squared, which is 2x minus 1 squared, plus 2 pi times 2x minus 1 times 2x minus 1, right? So now, again, we're going to use all the properties we just learned to multiply these polynomials together. So we have surface area times 2 pi times 2x minus 1. And 2x minus 1 squared is the same as 2x minus 1 times 2x minus 1. And we have plus 2 pi 2x minus 1, 2x minus 1. And you can see here that these two terms are exactly the same. So we can just say that we have two of those terms. So we can just say 2 times 2 pi 2x minus 1 and 2x minus 1, right? We just have two of these terms right here. So now let's multiply these binomials together, right? We could also multiply these two together, but I prefer to do the binomials first. Right, so we have 2 times 2 pi. Now we do 2x times 2x. We got 4x squared. Then we do 2x times negative 1. Again, this is using the commutative property, which says that 2x minus 1 times 2x minus 1 is the same thing as saying 2x times 2x minus 1 minus 1 2x minus 1, right? So we just multiply every term in this bracket times every term in those brackets. Erase this. Okay, so we have 4x squared, as I already said. Now 2x times negative 1 will get us minus 2x. Negative 1 times 2x, negative 2x. Negative 1 times negative 1 will get us positive 1. All right. Then we can say that we can collect like terms inside the brackets. We have 4x squared, and we add these up, right? We have negative 2x minus 2x. It's going to be negative 4x plus 1, right? And I'm running out of space here, but that's okay. Now we have surface area. It's going to equal 2. Now we're going to use the distributive property to multiply this 2 pi into every term, all right? So 2 pi times 4x squared is going to give us 8 pi x squared. 2 pi times negative 4x is going to give us negative 8 pi x. 2 pi times 1 is going to give us 2 pi. And now one last distributive property. Multiply this 2 by every term, right? I'm going to bring it, let's say, up here. I think it'll fit up here. We're going to say that surface area is going to equal 2 times 8 pi x squared. It's going to give us 16 pi x squared. 2 times negative 8 pi x is going to give us negative 16 pi x. And 2 times 2 pi is going to give us 4 pi. And that's going to be our simplified equation for the surface area given the radius and the height. Okay, so now we're just going to erase all this, and I'll cut the video. You don't have to see me erasing all this. Okay, so moving on to B, second part of this question, we have to simplify the volume equation, which is going to be V equals pi r squared h, right here. And I just noticed I erased the radius and the height. Put that back. 2x minus 1, and h is 2x minus 1. Right, so if we plug that in, we can say pi times 2x minus 1 squared, but that's the same thing as saying 2x minus 1 times 2x minus 1 times the height, which is 2x minus 1. Okay, so here we have 4 different terms, right? 4 different polynomials in a way. So we can choose really anything to multiply first, and I'm actually going to choose these two binomials. I'll multiply those first. I'm going to say pi times 2x minus 1. I'll multiply these two. Again, the first term by each term in the second bracket, and then the second term by each term in the second bracket. So 2x times 2x is going to be 4x squared. 2x times negative 1 is going to be negative 2x minus 1 times 2x is going to be negative 2x. Negative 1 times negative 1 is positive 1. If we collect like terms, we're going to get 4x squared minus 4x plus 1. Now, we're going to use the commutative property to say that this whole thing right here, same thing as saying 2x times 4x squared minus 4x plus 1 minus 1, or we don't even have to put this one here, 4x squared minus 4x plus 1. Now let's get rid of these brackets first, inside brackets first. You can say that 2x times 4x squared equals 8x cubed. 2x times negative 4x is going to be negative 8x squared. 2x times positive 1 is going to be 2x. Now this negative is multiplied by this whole bracket, so we're just going to switch around the signs. Positive 4x squared is going to be negative 4x squared. Negative 4x is going to be positive 4x. Positive 1 is going to be negative 1. Now we're going to collect like terms inside the brackets. So there's only 1x cubed. So we're going to keep that the same. Cross that out so we know we used it. Now we have a negative 8x squared and negative 4x squared. So negative 8 minus 4 is negative 12x squared. Cross these out so we know we used them. 2x plus 4x is going to be 6x. And then just a negative 1 left. Put it at the end. Now one last distributive property into every term using the pi. Now we can say that volume is the same thing as saying, volume is 8 pi x cubed minus 12 pi x squared plus 6 pi x minus pi. And that will be our simplified equation for volume. Okay, so now that we are done with multiplication, let's get into some factoring. Here we can see the different ways of factoring that we will take a look at in this lesson. So let's get straight into it. First, let's take a look at common factoring. We have already looked at this in the review, but we will briefly go over it again. If we see a common factor in each term, we can take that common factor outside of the brackets and leave everything else inside the brackets. So in this example here, we have an a as a common factor in each term. So we can take that out of the brackets and multiply it by whatever's left, the b, the c, and the d. This would be the same thing as saying this whole expression right here multiplied by a over a, right? If we multiply by a over a, it's the same thing as multiplying by 1, right? Because any number divided by itself will give you 1. So we are not changing the expression at all if we multiply times by a over a. And if we multiply by a over a, this is the same thing as saying a times 1 over a times ab plus ac plus ad, right? A times 1 over a will give you a over a, so the expression is still the same. And now we can use the associative property, and we can say that we can multiply 1 over a by each term inside the brackets, right? Which will get us ab over a plus ac over a plus ad over a. Now, if we just divide out the common a factor from the numerator and the denominator, we'll get left with a times b plus c plus d, which is this expression right here. And that's kind of how you can see that the expression doesn't change at all. You're just taking out a common term, a common factor, sorry. Now let's do a quick example to get even more familiar with common factoring. So we have this long polynomial 9 times x to the 6, y to the 5, z, plus 9x to the 5, y squared, z to the 7, minus 27, x to the 7, y to the 3, z squared, plus 81, x to the 8, y to the 5, and z. Okay, so let's take this step by step. Let's see what we can factor out of the coefficients first. The coefficients are 9, 9, 27, 81. So from this, I'm seeing that the highest common factor that we can divide out is 9, right? From the x's, right? The lowest x exponent is 5, right? If I'm not wrong. So we can factor out an x5. right here. This is the lowest one. From the y's, right, we can factor out, looks like a y squared. This is the lowest exponent on a y, or the smallest. And from the z's, I can see that z to the 1 is the lowest exponent, or the smallest exponent, sorry, that we have on a z, so we can factor out a z. And what are we left with inside the brackets? Let me erase all these. So if we divide this term by this, so we can say 9x to the 6, y to the 5z, divided by 9x5, y squared, z. So the 9's cancel out. This x5 goes away, and this gets turned to 1. This y squared goes away, and 5 minus 2 is going to be 3. And the z's are going to cancel out. So what are we left with? We're left with a 1 as a coefficient, an x, and a y cubed. So let's do that for every single term. This term divided by this, it's going to leave us with a 1 as a coefficient. It's going to leave us, oh, there's an x5 here. It's going to leave us with no x's, no y's, and it's going to leave us with 6 z's. Right? Next, negative 27 x to 7 y cubed and 7 squared. It's going to be negative. The coefficient, we have a 3 left, because once we multiply 9 by negative 3, we get back negative 27. Right? We have 2 x's left, x squared. Once we multiply x5 by x squared, we get x7 again, as we can see here. Then we have 1 y left and 1 z. And finally, we have this last term here. And if we divide by this term, we get left with a 9. We get left with 3 x's. We get left with 3 y's and no z's. And here, let's see if we have any like terms so we can add them up. It doesn't look like it, so this is going to be our final answer. And to check if that's the correct answer, of course, you do distributive property to every term, like that. And if you get this, then it's correct. Okay, so next we're gonna look into factoring by testing values, and this is one of my least preferred ways of factoring because it usually takes the longest, but it's still really important to know and understand. So what we need to do is plug in various x values, keeping them simple, so 1, 2, -1 maybe, into this function and calculate the numerical value it gives us. From this value, we have to find a certain pattern that we can kind of see and find what this whole polynomial factors to. So the terms that it factors to. So let's do an example to see how this all works, because it's really kind of hard to explain without an example. We have f of n equals n to the 3 plus 3n squared plus 2n plus 6. So let's test a few values. F of 1 is going to be 1 plus 3 plus 2 is going to be 6 plus 6 is going to be 12. Right? F of 2 is going to be 8 plus 4 times 3 is 12, 20 plus 4, it's going to be 24 plus 6 is going to be 30. Next, I'm going to see F3, then 3 cubed is going to be 27, plus 3 squared times 3, 27 plus 27 is going to give you 54, plus 6 is going to give you 60, plus 6 is going to give you 66. And let's do a couple more, but I'm going to pull out a calculator here. It's getting a little long and tedious. So 4 cubed can equal 64, plus 4 squared is 16, times 3 is going to give us 16 plus 16 is 32, plus 16 is 48, right? Plus 2 times 4 is 8, plus 6, 126. Okay, so these numbers don't look like much, but if we break them up, 12 is the same thing as saying 4 times 3. 30 is the same thing as saying 5 times 6. 66 is the same thing as 6 times 11. And 126 is the same as 7 times, divide that by 7, which I forgot what it was. It's 18. So what pattern do we see with these numbers with respect to variable n? Well, we can see that from the n value to this value, you're adding 3, right? 1 plus 3 is 4, 2 plus 3 is 5, 3 plus 3 is 6, 4 plus 3 is 7. So one of the terms might be n plus 3, one of the factor terms. Now, what pattern do we see with these numbers? Well, we got to really think about it here. But if we really think about it, we can see that a pattern emerges where you square the n value and then you add 2. So if you square 1, you add 2, you get 3. If you square 2, you get 4. You add 2, you get 6. If you square 3, you get 9. Plus 2, you get 11. If you squared 4, you get 16. Plus 2, you get 18. So we can say that the other term is n squared, which is again this variable over here, plus 2, right? And that will actually be our factored form of this function. So f of n will also, I'll put it up here, f of n will also equal this. So if you factor this whole polynomial, you get n plus 3 times n squared plus 2. And I know it's a little complicated to think about, and it takes a long time, and that's why it's one of my least preferred ways of factoring. But it's good to understand, it's good to know how to do it. Next, we have factoring by grouping, and using this method, we factor out a common factor from a collection of terms that have this common factor, so not from the whole expression. Once we take out that common factor, we will end up with the same expression inside the brackets, right? And then we can common factor that out to get a final expression in terms of multiplied polynomials, right? So in this example, we have a common factor of ax squared, which we factored out from these two terms, and we have a common factor of c, which we factor that out from these two terms. We get left with ax squared times x plus 1, and c times x plus 1, right? And then we can factor out an x plus 1 and get this final expression. So let's do an example for this. We got 2xy plus 2x minus 3y minus 3. So we can see what terms have common factors, what don't. We could common factor out a y from these two, but then we really don't have much to factor out from these two, right? It'll still work, right? And I'll show you both ways, but we can just take these two as well, right? We can factor out a term from both. And we can say that 2x can be factored out from the first two, and we'll get left with a y plus 1. And a negative 3 can be factored out of the other two, and we'll get left with a y plus 1. And now we have the same factor here, which we can take out, say y plus 1 times 2x minus 3. It's the same thing as the original expression, right? We could also do is rearrange this first expression, say 2x y minus 3y plus 2x minus 3. Now we can factor out a y from here. We can say y times 2x minus 3. And we can't really factor out anything from here, but that's a lie. We can actually factor out a positive 1. And we can put it here, but we don't have to. We can just say plus the brackets 2x minus 3. And now we have a common factor in 2x minus 3, and we can factor that out. We can just say 2x minus 3 times y plus 1, which is the same thing as this, so you'll get the answer both ways, but sometimes you won't get the answer if you rearrange the expression, or you won't get the answer if you don't rearrange the expression, right? So you got to try it both ways. Next, we have factoring as a difference of squares. For these types of questions, we just have to look for two terms that are a perfect square, meaning a number or a variable that can be multiplied by itself to get this term. And there must be a negative sign between them, like here, right? And what I mean by a perfect square is, for example, 4 is a perfect square because it can be multiplied. 2 can be multiplied by itself to get 4. 9x squared is a perfect square because 3x can be multiplied by itself. Oh, that looks kind of weird. To get 9x squared. And a squared, like up here, is a perfect square because a can be multiplied by itself to get a squared, right? So we look for that. We look for perfect squares with a negative sign between them, and we put it in this form. The square root of the first term, so square root of a squared equals a, minus the square root of the second term, so square root of b squared equals b, right here, times the square root of the first term plus square root of the second term, right? The reason why it can't be a squared plus b squared, you'd think it'd be a plus b and then a plus b. But once you multiply these two binomials, you get a squared plus ab plus ab plus b squared. And then you'll end up with this weird term in the middle of 2ab plus b squared, right? It wouldn't be this, right? So you need a negative sign, not a positive sign. Okay, so now let's do the example. 25x squared minus 49 plus 1 minus y squared, right? So these are all perfect squares. So we can go ahead and take these two, for example, right? They're both perfect squares and they have a negative sign between them. So we can use factoring by a difference of squares. We can say, let's say this is our a value, like up here. 25x squared, the square root of that, 25x squared, is 5x. The square root of 49 is 7, right? And the first bracket is, there's a minus sign. The second bracket, there's a positive sign, right? And then we can do these two. So we can say plus, square root of 1 is just 1. Square root of y squared is y. And then we can say 1 plus y, right? Just putting it in this form. And we just do the square root of the first number minus the square root of the second number, and then the square root of the first number plus the square root of the second number. It's very simple. And that's pretty much your final answer. Lastly, we have trinomial factoring, which again, we've gone over in the review. And for trinomial factoring, if the a value, this value right here, is 1, we want to put it in this form. If the a value is not 1, right, we want to put it in this form. Okay? So, the a value is 1, remember, we want to find two numbers, m and n, which add up to b and multiply to c. And then we put it in this form, right? The variable plus the first value, variable plus the second value. And if a does not equal 1, we want to find two numbers that add to b and two numbers that multiply to a times c. So if the numbers are r and l, the numbers r plus l must equal b, and the numbers r times l must equal a times c, right? Then we have ax squared plus rx plus lx plus c, and then we use composition. We use factoring by grouping to get to this form, right? Like we've done before. So if you fell asleep when I did it before in the review, let's do another example. 4x cubed minus 6s squared plus 2x. So here we can see that we can common factor out. Firstly, before everything, you want to see if you can common factor out a term because it will make what you have to factor inside the brackets much easier. So from here, we can factor out, it looks like a 2 and an x. If we factor out a 2x, we get left with a 2x squared minus 3x plus 1, right? If you multiply that out again, you'll get this. So now we want to factor out what's inside the brackets. And as you can see, it's much easier than this, degree of 3 polynomial. So let's keep factoring. We have a complex trinomial, so the a value does not equal 1. So now we have to find two numbers that multiply. Let's say the numbers again are r and l. So r plus l must be -3, and r times l must be 2. 2 times 1 is 2, right? So what are these numbers? What numbers add up to 3 and multiply to 2? Well, the numbers, you can say that 2x squared, remember we're going to put it in the form of plus rx plus lx, right? So the numbers that you need to get are 2x and negative x plus 1. Because negative 2 plus negative 1 will give you negative 3, and negative 2 times negative 1 will give you 2, right? And now if we factor by grouping here, we can say that we can factor out a 2x from this side, we get left with an x minus 1, and we can factor out a negative 1 from this side, and we get left with x minus 1. Now, if we factor out that x minus 1, we get left with x minus 1 times 2x minus 1. And this is our final answer. Okay, and that's it for this lesson. I hope everybody is following along well and understanding these concepts so far, and remember to always keep practicing.